Hey everyone, let's look at the lesson 14 practice set. Um, so we're working our way from equations into inequalities now, which are very similar, right? It's still a statement about two quantities here or two expressions, but equations say, hey, this is the same as this, right? Equal. But inequalities say, hey, this is more than this, or this is less than that, or maybe they're less than or equal to, right? Or whatever. But it's still the same idea, right? Building these statements from word problems or from these balance diagrams about comparing two sides of an inequality sign. So let's do it. We got the warm up here. I'm working in the book today. I think Mr. Wong's students, you usually work in the book, so that's fine. If you're in my class, you're probably working online. That's perfectly fine. The questions should be the same. If you want to do it in your book, you can. So it says select all of the values that are solutions to x is less than or equal to -4. So being a solution to an inequality means it's a number that makes the inequality a true statement when you substitute the number for the variable. So like for this first one, we need to be able to put 4 where x is and get a true statement. That would make 4 a solution. So we could rewrite this instead of x is less than or equal to -4. We just put the 4 there and we get 4 is less than or equal to -4. That's obviously not a true statement, right? 4 isn't less than -4 or equal to -4. So no, I would not select that. The next one, so I probably won't write all of these out. We can do them just looking at them now. -4 is less than or equal to -4. That's what this one would say. That's true, right? Less than or equal, they're equal. So let's check that. Here we have -3.99 is less than or equal to -4. That's a tricky one, but no, -4 is more negative than -3.99. So -4 is the lesser than one. -3.99 is actually greater than -4, so we would not select that. But for that same reason, we should select -4.01, right? That's just barely less than -4, so that's a good one. The last one is 0. That's not less than or equal to -4, right? A negative number is less than 0. So I think these are the only two we're going to select. The one that's just barely less than -4 and the one that's equal to -4. And let's move on. So we have question 1.1. It says, write an inequality to represent the relationship of the weights on this hanger here. Use T to represent the weight of the triangles. Okay, so this is going to be T. This will be a T, and this will be a T. So we don't know how much each triangle weighs. These are supposed to be little T's. They're kind of hard to see. We don't know how much each triangle weighs. So we're making a variable to stand for that weight. It's T. We don't know what it is. We're going to call it T. And we're also supposed to use C to represent the weight of the circle in grams. But it's showing us 6. Oh, okay, I guess we're supposed to do it with C first. Well, on one side of the hanger, I have 3T, right? 1, 2, 3, 3T. So let me write that. And I notice that the T's are heavier, right? They're pulling their side of the diagram down. And so if you think about weights, right, and if you put two weights on a scale, the heavier one's going to go down. So that means that the 3T must be more or greater than whatever's on the other side, which is, I see two weights that each weigh 6, but the question's telling us to use C to represent the weight of the circle. So this is supposed to be a C, and this is supposed to be a C. So we have two C's. So our inequality here says 3 triangles are greater than or way more than 2 circles, 2C. Okay, and so now in question 1.2, it's clarifying. Each circle weighs 6 grams. So now we have that information, even though we kind of already saw it there. Write an inequality to represent the weight of one triangle. Okay, well, we know that 3 triangles has to be heavier than 12. I got that 12 from the fact that there's 2 circles over here. 6 plus 6 makes 12. And now this is where we get into solving inequalities the same way that we solve equations. You can do the same things to equations or to inequalities that you can to equations. I want to isolate that variable. I want to see t is greater than something, not 3t. So let me divide both sides by 3 to get rid of that 3, the same way I would do it if there was an equal sign there and I was doing an equation. And I get t must be then greater than 4. So this tells me that each one of these triangles must weigh more than 4 pounds in order for 3 of them to weigh more than those 2 6-pound weights combined. And so you can solve inequalities the same way we learned how to practice equations, except there's one special weird trick about it that involves negative numbers that I don't think we're ready to really get into just yet. So I'm going to leave that as sort of a secret mystery. But other than that, pretty much anything you can do with equations, you can do with inequalities. All right, and so now down here, it's saying, let's draw the solution set for each inequality. So when you solve the equations that we work on in 7th grade, oops, I went the wrong way. Those equations only have one solution, the ones that we do in 7th grade. Lots of equations have more than one solution. Some of them have infinitely many solutions. But the ones we've been doing so far just have one. You find the one solution at the end, x equals 3 or whatever, you're done, yay. Well, inequalities are different. They have what's called a solution set, a set of things, meaning you have more than one, right? And that's because when you write an inequality like t minus 4, sorry, I don't know why I said minus, t is greater than 4, there's lots of numbers that are greater than 4, right? 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, a billion, whatever. There's so many numbers that are greater than 4. Well, all those numbers are called the solution set for this inequality. And so now we're going to write the solution set for these inequalities. We have to solve them first because it's really hard to figure out what the solution set, maybe if I zoom out, there we go, that makes life a little better. It's really hard to figure out what the solution set to an inequality is unless you have the variable isolated. Once you have the variable isolated, then it's pretty easy to see. So I'm going to solve this just like I would an equation. I've got 5 times x here. I want to divide both sides of this inequality by 5. And I'm left with x is less than or equal to.
Please. Jalen, can you please come to the office?
So we have x isolated now. I still have my less than or equal to sign. And then negative 20 divided by 5 is negative 4. So the solution set to this inequality would be any number that's less than or equal to negative 4. So what we do is we go to negative 4 on the number line. And then we think, okay, less than, that's that way. That's to the left. All the numbers less than are going to be over here. So we like shade those numbers or we draw a line over them. But the first thing you have to think about is, what do I put at negative 4? You have 2 options. You're either going to put a circle that's not filled in, or you're going to put a circle that is filled in. And whether you fill it in or not entirely depends on whether or not you have this little equal bar right here at the bottom of your inequality sign. If that equal bar is there, then you fill in the circle on your number where you're going to start your solution set. And the reason for that is that indicates to someone who's looking at your graph that negative 4 is a part of your solution set. You're saying that negative 4 works. Negative 4 is a solution because negative 4 is indeed less than or equal to negative 4. Well, negative 4 counts, right? It's equal. So we color in the dot, or we fill in the dot over -4. And then we just drew an arrow. Some people squiggly, some people just put a line, whatever. I'm just gonna do a line like this with an arrow on it, pointing that all the numbers that direction on the number line are part of this solution set. If you're actually working online, you have the little thing to drag, right? Like you drag the circle over the -4. You click it so that it's filled in, right? Don't leave it as a hollow circle. That's wrong. And then you just change the line on the little graph online so that it's pointing that way. All right, and so let's do the next one. 11 is greater than 2x plus 1. We solve it just like an equation. I'm going to subtract 1 from both sides, and I get 10 is greater than 2x. And so when I divide both sides by 2, I don't really have enough space here to show it, so I'm going to skip showing the step. But I'm dividing both sides by 2, and I get 5 is greater than x. I'm going to switch colors. So look, I don't have the little equal bar this time. That means 5 is not a solution to this inequality. You can't put 5 here where x is, because 5 isn't greater than 5. That's not true. 5 and 5 are equal. So when I go to 5 on the number line this time, I have to leave the circle open, as a mathematician would call it. Mathematician would call this an open circle, and would call this one a closed circle. And so my circle's open, and now this is tricky. It says 5 is greater than x. You see the greater than sign, and you're tempted to shade in the greater than direction. But think about what it says. It says 5 has to be greater than any number you put in for x. And that means x has to be all the numbers less than 5, right? It's almost better if you read this one backwards. Instead of saying 5 is greater than x, you should think of it as x is less than 7 or 5. Why did I say 7? What's wrong with my brain right now? It's Friday afternoon. I think I'm ready to go home and enjoy this 3-day weekend. All right, so I'm going to draw this arrow going in the less than direction. And there you go. There's your solution set for that one. Let's do the next one. All right, so the last one says 2 times the quantity x plus 3 is greater than 18. I'm going to start this one by dividing both sides by 2 to get rid of this factor of 2 that's outside the parentheses. So I'll do it here as well. And what I'm left with is x plus 3 is greater than 9. Now I just subtract 3 from both sides to get rid of that, right? -3, -3, and I get x is greater than 6. All right, so I notice, it's pretty bad greater than sign. I notice first that I do not have the equal bar. So it's not x is greater than or equal to 6, just x has to be strictly greater than 6 is what a mathematician would say. All right, so let me go to 6 on the number line, and I'm going to leave an open circle. That indicates that 6 is not a solution. And then I draw my arrow toward all the numbers that are greater than 6, because that's what's going to solve for x in this case. Okay, we call this our solution set. All the numbers that work for x, we call that our solution set, and we represent them with these number line graphs, diagrams, I don't know, whatever you want to call them. All right, let's move on. Pull this thing back. List at least 3 values that would make 5x is less than or equal to -20 true. Well, we solved this, right? This is the same question they asked us right here. And I divided both sides by 5, and we isolated x. X is supposed to be less than or equal to -4. So I'm going to write that over here. X is less than or equal to -4. And so we're supposed to list 3 values that work for that. So that just means just list 3 values that are either equal to or less than -4. I'm going to start with -4 because that's equal to -4, right? So that works. Now I just need smaller numbers. That means more negative or bigger negative, if you like to think of it that way. How about -10? How about -412? There you go. There's your 3 values. Maybe you should think of 3 different ones. All right, how are the solutions to the inequality 5x is less than or equal to negative 20 different from the solutions to 5x is strictly less than, right? That's when I say strictly less than, I'm referring to the fact that this less than sign does not have the equal bar on it. So this is less than or equal to, and this is just less than, or you could say strictly less than, negative 20. They're exactly the same. These solution sets are exactly the same. All the same numbers make this one true and this one true, except for one single number, right there. Negative 4 is part of the solution set for this one because it's allowed to be equal. Negative 4 is not a part of the solution set for this one because it's not allowed to be equal. So I would say it like this. The solution sets are the same except negative 4 is a solution to 5x is less than or equal to negative 20 and not 5x is strictly less than negative 20. If you're working online, if you're working online, this might be kind of hard to do. I don't know if you can do the less than or equal sign. Like, yeah, I don't know how you would type this. And so if you're working online and you just want to say the first one and not the second one or something like that, that works. All right, so the price of a pair of earrings is $22, but Deja buys them on sale for $13.20. How much did Deja save? All right, well, that's pretty easy. We just do $22 minus $13.20. Let's see here. 7 plus 13 is 20. So 8 gets me to 21. So 9 would get me to 22, but I don't want to go to 22 because I got this 20 cents here. So I think I want $8. And then if I have 20 cents and I add an extra 80 cents, that gets me to the next dollar, right? So $8.80, I think. So what was the percentage of the discount? This is what we math teachers call spiraling. We're revisiting an old topic to see if you remember it. So we need to find a percent. Well, the way we always did it in my class, I forget how Mr. Wong showed his class to do it. We had these little formulas. Percent equals part divided by whole. And so in this case, we want to find out what is the percent, or sorry, what is the discount amount? What is this, the discount, out of the whole original price, right? So the discount is like a part of the price. And the original price, ooh, my handwriting got weird there because the paper's all curled up. But the original price is like your whole. That's the whole thing that you started with. And so if you want this as a percent, you just take this part that got discounted off and divide it by the whole amount that you started with. And let's see here, 8 out of 22, that feels like it should be a little bit more than a third, right? Because I know 8 is 1/3 of 24. So it has to be more than a third out of a smaller number like 22. So I don't know, I'm gonna guess 40-ish%. That's my guess. Let's see. It's always good to have these little guesses before you start something like this, because then if you get some wild answer like negative 842, you already know it's wrong before you started and you know to try it again. All right, so we're doing 880 divided by 22, and we get, hey, there you go, 0.4. That's not 4%, that's 40%, because that 4 is in the 10th spot. So I called it. I promise I hadn't done this question before, I was estimating. So that equals 0.4, which is 40%. I like this pink marker. right, we get, we're on the explore now. Okay, write a value in each region that makes the inequality or inequalities true. Well, this is weird. I've never seen this symbol before. I think this is supposed to be less than or equal to, but like the equal to bar is like slanted. I think that's just a typo. I don't think that's a math symbol I've never seen before. So I'm just gonna assume that that's a less than or equal to bar. All right, so we got 18 minus x is less than 0. So we have to pick a value here so that if you started with 18 and you subtracted whatever number we put here, it has to come out to less than 0. Okay, 20 would work, right? 18 minus 20, that gets you into the negatives. I'm gonna throw a 20 here. This one, this 18 minus 2x is less than or equal to 0. So it's just another one where we're subtracting something from 18, but it has to get you less than or equal to 0. Oh, wait. Oh, geez, how embarrassing. I'm just not realizing I looked at that symbol wrong, huh? That says greater than. So 18 minus something is greater than 0. So how about 10 then? Right, 18 minus 10 would be only 8. So greater than 0. Right, this one, on the other hand, 18 minus something, which 2x has to be less than or equal to 0. Well, we could just pick a really big number here, right? If you subtract 18 minus 100, well, that's certainly going to be less than or equal to 0. So how about if I make x 50, right? If I make x 50, then 2 times 50 is 100. 18 minus 100, that's way less than or 0. So that's fine. Here's the tricky part. We got to fill in this part of the diagram. This part of the diagram can only be filled in with a value that is true for both inequalities. Okay. A little guess and check. What if it was 5? 18 minus 5 greater than 0? And 18 minus 2 times 5 less than or equal to 0? This one works, right? 18 minus 5 is 0. Is bigger than 0, right? It's only 13. 18 minus 2 times 5, which is 10, that's not less than or equal to 0. Okay. I think I need a bigger number because I have a lot of space to work with here, right? 18 minus 5 is greater than 0. I only went to 13. I could put a bigger number here and still be greater than 0. And I need a bigger number here so that I can get this one less than 0. So let's try 10. I mean, I put 10 over here, so I know 10 works for the first one, right? I already tried that. Does 10 work for the other one? 18 minus 2 times 10, is that less than or equal to 0? That's negative 2, right? Negative 2 is less than or equal to 0. So 10 works there in the center as well. All right, there's your practice 7.14 or 7.614, whatever. You know what I'm saying. I'll see you next time. Later.